our topic is reducing the greenhouse gas emissions from light vehicles.
Yep.
So we would like to start especially targeting the hybrid and electric vehicles. When you ever buy any vehicle, especially of those two categories, you will come across a term known as regenerative braking. Well, the regenerative braking is generating the waste power or reusing the waste power to overcome the acceleration, like to again accelerate the vehicle. It's that power that has been captured and it's again using. So generally, right now, currently, we have batteries to store those power. The problem with the batteries is that its life cycle is too less. Its life cycle is too less. The second thing is that, as you can see from the picture, there's a problem that electric vehicle, that the lithium ion is highly flammable, so it can catch fire in a hold position. And the third most thing is that during the extraction process of lithium from the ground and making it into a reusable form, it generally emits a high amount of greenhouse gas emissions. So to overcome all the problems, what we are suggesting is a better alternative than a battery. And this is the Reagan plot that we would like to show. And in that you can see a supercapacitor. So we are targeting the supercapacitor as an alternative, as a feasible alternative for in place of batteries. So how is the supercapacitor work? Supercapacitor is nothing but it is it's giving a high power density to any electronic device. High power density means it's giving a boost. So what we have implemented is that we are working on a material, biodegradable material, and we are making the material from the scratch using the bio waste. So it's like making from the scratch and giving back to the earth biosphere. So it's totally a circular economy. So that's the first thing that we want to target. Second thing is that the fuel efficiency from this supercapacitor will improve the overall efficiency of the hybrid vehicle. The third thing is that we want to talk is that it's a technology neutral, that our product is technology neutral. It means that the customers are not forced to switch over to our technology. It will be on them whether to switch over to us or to have the batteries. The next part of the pitch will be presented by the Rini. Rini, over to you.
Hi everyone. So yeah, now I'll be discussing the customer segmentation slide of this project. Basically, as you can see, we will be targeting the local and overseas buyers, but the main target of this project will be the government fleet, which includes federal, territorial, and the state government, and also we'll be targeting on non-profit organizations and dealers and other large fleets, etc. And so yeah, these were the customers. Now this project's futuristic approach basically focuses on three main things: the environmental, now it's basically the environmental benefits of this particular project, then technological, which is the uses of less components for a better product, and the societal, maintaining the relationship between the key stakeholders and the management team of this particular project. And so yeah, now I'll be talking about the key stakeholders. So basically, as you can see, these blue tiles show all the key stakeholders involved in this particular project. So battery firms like Murata and Maxwell, now these are the leading battery firms. So we will be basically needing their guidance for this project, and then the automotive industries and investors, and then ARENA, CSIRO, Australian Research Council, and these are the governing bodies which will basically be giving us the guidance, like how to work on this project and etc. And then for the financial issues, like for the handling of the financial flow and everything, we'll be having Australian stable banking systems and regulatory systems by our side. Now these were the key stakeholders. Now we will need some ways on as to how to reach them. So basically there are several ways, like
2 minutes left here, just
warning. Yeah, sure, just a little bit.
Yeah.
So, these different ways are basically we will be having our retail stores from our partner channels, then some various online stores, then conferences for this project, and some on-site employees and the surveys. So yeah, these were the ways on how to connect with our key stakeholders. So yeah, that's it. Thank you.
Thank you very much.
Excellent. So, is there any conclusion from this? Any one sentence conclusion from this work? That's my first question.
Okay.
So,
Siddharth, would you like to answer?
yeah, just give a conclusion. What you like to achieve in one sentence from this project in terms of the outcome?
Okay. I will answer it.
Yeah.
Sir, the outcome of this project is nothing but implementing the current technology. It's a market pull. That what we are suggesting is a market pull, not technology push. The first thing, because
Yeah.
batteries are the feasible option at the most moment, but looking in the forward direction, so we have to think about the environment. Batteries are feasible options. It's like investing a little bit of capital and gaining a huge return in terms of economic and non-economic benefits. So
your focus is environmental. You would like to make environment more safe by
no, sir.
Is it
Along with environment, it's also the human safety. As you can see,
Yeah.
the lithium ion is highly flammable. So if you are going to charge it for almost like more than 5 or 6 hours, so there might be chance, because it's an electronic, it's a device, so it can catch fire on its own. So we don't even know. So we have to be safe, and so we are suggesting, because there is no such harmful effects, or there no such detrimental effects with the supercapacitor, as it's having the low resistance.
Okay. Okay. Excellent. So thanks, Madhav. So I'd like to go to the next person asking. So what about the cost when you develop this supercapacitor? Have you done any cost analysis compared to the other solution? Will that be more expensive, or just to give an idea? Yeah.
Yes, sir. Hi, I'm Siddharth. I will answer this question for the
Are you
group.
Siddharth? If I'm not wrong.
Yes, sir.
Yeah.
Yes, sir.
Okay. Thanks. Yeah.
So basically, we have not done an exhaustive financial and economic analysis on the paper, but we have studied about it over the internet. We have studied the data. The cost actually comes down because the capacitors are having much more lifetime as compared to the lithium-ion batteries. As Madhav, our presenter, told you, like lithium-ion batteries that we also use in our phones, that is quite flammable, and also there is some news going on. There are news going on like it catches fire, and so basically we are trying to avoid that thing, because in future we don't want anything harmful for our customers or our any stakeholders. And we have studied about this, and considering that supercapacitors are having a much more life cycle as compared to the lithium-ion battery, that will reduce down the cost maybe like almost like 1/3 or one fourth, like that much. Because if the lithium-ion batteries are a bit cheap, but they don't have that lifetime, and supercapacitors being on a particular higher side, but it also gives us a much more high life cycle. So when we compared both of them, so we came to a conclusion that okay, the supercapacitors are a better choice over them, because they also runs for a longer period, and also for the long term the money also gets some inflation. So taking all those things, we I would like to say that okay, the supercapacitors are a better choice economically and financially.
Yeah. So next person, thanks, Siddharth. That's good.
Yes, sir.
So the next person, probably you are 3 members in this team, if I'm not wrong, or 4 members. So like to ask, other than supercapacitors, how can we reduce or minimize the effect of fire in the electric vehicle? Is there have you done any literature study? What are existing solution people already offered?
We have not looked at other technology, but looking at this the supercapacitor, they have less harmful chemicals, which is making it less to explode, unlike the other batteries, normal battery, the lithium ion.
Yeah. So
Yes,
Nisa,
sir.
thank you. So Siddharth, yeah. Yep.
Yes, sir. Like I would like to like compliment Nisa with this.
Yeah.
While going through all this uh, study and all, I came across one thing like lightweighting of the vehicles. So basically, our project was running across the superconductors and everything. So I also told Madhav like, okay, we can do that, but it is not a technological revolution or something like that. But it
Yeah.
can be considered as the lightweighting of vehicle will help with like if you're considering a vehicle which is made of steel or iron or heavy metal, and if you consider a vehicle that is made of aluminum, which is a lighter metal, so the amount of power that is needed by the motor will be lesser uh, in the what to say in the aluminum vehicle, because the weight that it has to carry is less. So that
Yes,
is
yes, Siddharth. My question is, you propose to come up with a super capacitor which will
yes, sir.
reduce the effect. But is there any other technology other than supercapacitor that people are proposed or applied or trying in the literature? That's my question. Other than supercapacitor, I understand supercapacitor is one of the option, and you're
Yes, sir.
proposing um, this technology. But what others have done in this area?
So, like I have read about many things, but majorly three things come up in this. Uh,
Yeah,
like
just
one,
give me
like
one.
when we, yeah,
Just give
when we
me.
talk about basically greenhouse gas emissions to lower them, we talk about like electrification of the vehicles, lightweighting of the vehicles, and using a different alternative as compared to the lithium-ion battery. So we have considered the superconductors. So
But
basically,
but
what
uh,
we
but your problem statement saying you want to reduce the fire because that's a problem with the lithium-ion battery. So now the lightweight
uh
question become out of
yes,
scope
sir.
because your objective is not to make a lightweight vehicle. Your objective is to minimize the effect of fire.
No,
Yes, sir.
I would like to add more, sir.
Yes,
The
yes,
fi-
mother.
yes, sir. The fire which has been shown is just a pictorial representation of a common problem with the lithium-ion batteries. The main
Yeah.
problem is with the manufacturing of the lithium-ion. We only talk about the life cycle of the car. We don't talk about the previous, like how the battery has been manufactured, or
Yeah.
what type of electrolyte is being used. In the
Mhm.
supercapacitor, we don't have any such liquid electrolyte. We have activated carbon. If I can show you in a bit, you can see on the left hand side, sir, it's an
Yeah.
activated carbon. Uh, and it doesn't catch fire because it's highly wrapped in the carbon electrode, so it won't like it doesn't catch fire.
So
uh,
it is a fire retardant. That's what I mean. So
no,
it's
yeah,
some.
it's a fire resistant. That's the
Yeah.
one property. That's the one property. The main property is with the we are proposing a better alternative, because during the manufacture of these batteries to use in the electric vehicles, uh, the regenerative braking, as I started from basic, the power which is being captured using the batteries is a bit lower if we compare with the supercapacitor used instead of that.
Yep. Yep.
I would like to improve the braking efficiency. I would like to improve the life cycle of the vehicle, as well
Mm.
as keeping the safety of the customer, my client, or any other human being. That's
Okay.
my
Okay.
main.
Excellent. Excellent, mother. So yeah, your time is up.